Yeah, let's start it. I hope it's fine now. Yeah. So yeah, in last class we have seen how to build our own images, right? On top of some base image. Why? I mean, to have our own images with our data, with our application, with all the dependencies and everything. So we have images ready now. So maybe this is one image we have built, correct? Let's build again. Maybe let's delete this. So I delete it. Now let's build our own image. Docker build. Hope you know this command. Nginx app hyphen F, what is my Docker file name? Nginx Docker file. If it is just Docker file with capital D, you can just simply use dot. It'll automatically find it. If it is in the current path. But the file name is different, which is present in the current path, just do this. So hyphen F we have to pass. Because we're explicitly telling where the image is and what is the name of the image if the name is different. And where is the path? Dot obviously. So that's why we gave the dot. Enter. Let's building layer by layer. Based on the layers what we have written. Missing file operand. I gave something wrong. Why? Because in Nginx, I'm using arguments, if, and I'm using the argument even for a command also. If I don't pass any argument, it will throw error. Correct? Let's build again. So let's build docker build command, but pass I build arg because it's expecting the build arg. I mean, in some cases, you don't need to pass the build arg. It automatic. If you don't pass anything, it won't do anything for that. But here we are using the build arg in a command, so the command will fail if you don't pass the argument. So builder, what is it? A, right? Open correct. A is equal to maybe test 2, 3 something, whatever it is. Let's try. Still, it's failing. Well, I think, yeah, the argument is test, not A. Sorry, my bad. The argument is test, not A. So this is the argument name. Let's see now. So now it took without any error successfully built. If you observe now, second time I ran. Let's run it again. I ran all the layers. This is what we have written. Correct? Argument DNA, blah blah something. And if you observe here, it's something called using cache. What does it mean is, you know what is obviously, but in the Docker file, we have some instructions. And first time when we build it, it will build from beginning. If each and every layer, each and every instruction what we wrote, it will build it. But next time, let's say we ran the same Docker file, we executed the same Docker file. If there are no changes inside the Docker file, it will take it from cache. Let's say the command didn't change, right? We didn't change anything, correct, in anywhere. So that's why using cache, using cache. See, in every stage it will be there. Every stage there will be a command called using cache. Because if there are no changes, it will take it. It will take from the cache. If there is a change, it won't take it. It will remove the cache and execute again. Now let's see if I do open Docker file. Maybe I'll change what to change. I can add some more command. Sorry, apt install something curl life and life. I don't require this, but yeah, let's try. It means the cache should be removed for this stage because I changed it. Let's see how it works. Will it? Is the cache gone? There is no cache. No cache, isn't it? If I run this one without changing again, from cache, let's say, sorry, let's remove this again. I don't need it. Now again I changed it. Let's see whether it take cache or not. It took cache. So why? Because the task is already done. If you remove it, so nothing will happen. If you add something extra, anything changed, then it will work. Then the cache will work. So let's say I have written some line called copy. Copy some data. Let's write that. Maybe after this. Yeah, this. Copy, sorry, index.html to slash user slash slash share slash nginx. This is path it's expecting. From current path, it is where I'm copying it. Let's say index.html and something. It copied. See, the cache is gone here. If you observe here, cache is there on top of it because we didn't change these things. We changed only this one. So cache is removed for this one. And the one below it also. See, if I change a command, the command and whatever the commands below that, those cache will be gone. See, I added this, and of course, this is the first time, so no cache. And this cache also removed because this is once this is gone, the next one also will be gone. It means if I change something in this command, the cache will be gone to all of these things. It will rebuild again, whatever the commands below that. Now let's say I didn't change anything. So let's run nothing, no, all our cache. Now what I'll do, I'll change the index.html file. Hi, hello. This this is a test for Docker build cache, something, whatever. I'm just writing something. Now the content change. Let's see whether it'll take cache or copy. Copy. We remove the cache and copy it. See, cache gone because I changed the content here. It means something is changed in this file, whatever I'm copying. So that's why cache is removed. Let's change this command here. This run command. Let's say starting. Hmm, Nginx and some other package. Now what happens? The cache will be gone for this and for the commands which are that one. No matter how many. So it will remove cache for all of them and it will build again. Let's see. See, it is building and obviously next instructions cache also will be gone. See, do you see cache anywhere now? It's gone because we changed the command and whatever the commands after that, gone. Cache is gone. So like that, Docker cache works. So got it for this one. I mean, how to what is cache and how this works based on the Docker file, based on the content or data we change. Let's say I'll execute all is there. See all okay. Let's say you got a scenario. I don't want the Docker file to use cache at all. Every time I build, it should build from scratch only. It's not required, but let's say scenario that like that you have. What to do then? I mean, I don't want to use cache at all. If I execute a Docker build command, it should not use cache at all for every command. It will start build from here without cache and until the end of the Docker file. The time what you do is simply for the command at the last, simply define hyphen hyphen no hyphen cache. It won't use cache. It will build from starting every time if you use this argument. See? And we didn't change anything. We just added the no cache argument. See, let's build again. See, no cache. See, nothing. Because we particularly saying no cache, don't use cache. That's why, like this. So you got it. What is Docker cache? You got it. Cool. Uh, that's about cache. Let's go to the next small topic. If you observe in this Docker build output here, for every stage, it's something running in AB some random, removing intermediate container, running in something, removing intermediate container, running in something, removing intermediate container. See, what is this? Everything. For every instruction, there will be like this. See, sorry, this one. What is this exactly? So what happens is when you build a Docker file, obviously it will go from stage by stage. I mean, the layer by layer, layers usually call it, or stages. So it will go layer by layer, right? Whatever the command we give, it will execute it. But how, where it will execute? It will create a container actually internal inside. It will create a temporary container and execute the command in the container. Once the command is success, it will delete the container. That's what we call intermediate containers. Let's see how it works. We don't do anything for this. We don't do anything for this. We execute a Docker file. For each and every layer, it will create an intermediate container and it will delete it after task is done. Let's say if task failed, I mean the layer failed for some reason, command is wrong or whatever it is, the container will be present. No contains. Sorry. My bad. See, 9 minutes ago. Did we run this? No. Because it failed the touch because we didn't pass any argument. Due to this, it failed. Let's try this. It will be refreshed for every 2 seconds if you do watch. Let's execute the command no cache and I'll remove the argument because it will fail obviously. Fast. Sorry. What did I give wrong? Build arg I'll remove. Sorry. If I pass build arg, I need to pass the value. My bad. See, it's created a container. Once this task is done, observe that it will go. I mean, once this layer is done. See, it's done. See, another one came and that will be failed. That will be stopped because we didn't pass the argument. If we pass it, let's say pass. Yeah, like this. Let's pass. First. See, the container is created. Done. See, the container is gone. Whatever it started. It's not just one container. For each and every layer, it will create separate container and it will execute in that container. But these are all, I mean, not even commands. Very, it won't even last 1 second. We didn't see this much. I mean, difference here. But for every stage, it will create a container. Sorry. See these containers because see the command failed in one layer. The container stopped because it created a container and tried to run the command, but it failed. The container stopped, and our Docker file also failed. Got it? Got it? What I'm saying? These are called intermediate containers. They'll create one. We build the image. and they'll be deleted automatically once the Docker layer, I mean the stage is success. If it is not success, it will be like this in exited state. You can see the container. Is it clear? That's called intermediate containers. We don't do anything for them. We don't do anything for those. It will just get automatically deleted. Nothing in our hands except writing Docker file. That's it. So yeah, that's about intermediate containers. So with this, we closed the Docker file topic. Let's go to a new topic today. It won't take much time. It's easy. You know this concept. You just have to know the commands. That's it. That is called how you manage the Docker files. I mean, sorry, Docker images. We have built your Docker images in your. This is let's say my laptop. My Docker file is in my laptop. I want to share it to my colleague or some other teammate. How to do that? How to do it? So one way is there are two ways to do it. So one way is like to store the Docker file in a tar file. I mean, this is sorry, this is sorry to store the Docker image in a tar file or zip file and use SCP to share the file to that guy, whoever is. That is one approach. Another approach is like another approach is like use a Docker hub, share to Docker hub, and let them download. Just like how we download it, like right Docker pull. So let them download like that. So like this. But let's try the first way. We will try one by one. Let's try the first way. How to share our Docker images. The first way is using Docker commands. There are commands called Docker save, and there is Docker save and load. So let's try that. What is save, what is load, blah blah something like these things. Okay. So now let's say my image. This is my image. Nginx app, correct? I want to share it to my colleague because he wants to use it. Why to build again? I just already built, so I simply share to him. So how to do it? Let's try. Docker save. Docker save. Give the file name. File name should be like a tar file or zip file, anything. Since it's Linux, let's use tar file, tar.gz files. I want to use maybe nginx.tar.gz. This is the file, and what is the image? The image name. Sorry, my bad, my bad, my bad. So Docker save. First thing is what is the image that you want to save? Nginx. This is an app. This is my image name. Where to save? Greater than symbol. Nginx. In this file, I want to save it. No output. You don't see an output. Type it. Where is this? See, the image is saved in this file. You may ask, like why can't I simply share the image directly? You can't share it. Image will be stored obviously in varlib docker. There will be images directory, but these are like multiple files. So it's not a single file to share directly to share an image. It's not. It won't work. So that's why we need to store in a file and share the file. Now do SCP. SCP, what is the source? Nginx dot the remote address slash the path. Share it to them. Got it? So like that. So you can share it. Now let's say I've shared. Let's say let's say I've shared it. All good. How he uses it? It's a file, right? I need in this format, in the image format. It's a file, zip file. How to use it? So we have to extract the image out of it. Sorry. Yeah. So now what I did is with the Docker save, I stored the image into a file and I shared the file because I can't share the image directly. All good. So my colleague he got the star file. But how to use it? You have to extract the image out of the file. How to extract? The command called docker load will help you. Docker load minus I means image. What is the file name? Nginx dot tar dot zz. So untag loaded image. So that the image is extracted from the file. Let's see output one more time. Now let's delete this image. I mean, since I don't have two machines, I'm just showing in single machine. Now let's see. There is an image. There is no image, right? Nginx image. See, there is no Nginx image. I have image in this file. How to do that? Docker load hyphen I nginx not tar not gz enter. See, it's extracting. Let's load Docker images. See, the image is present, right? That's how. One command is save. We are saving the image into a file, tar file like this one. And another command is to extract the image out of it. To get the image out of it, we're using load. So got it? Docker save and Docker load. These are the commands to save in the file. If you ask me, do we use it? Very rarely I've used it. Very good, but it's good to know. It's good to know what it does exactly. Because how many you share? Let's say I shared the image to my colleague now. Maybe after half an hour, I updated the image. I mean, I updated the Docker file and rebuilt the image. Now changes are there, right? Again, I have to share. Like that, how many times you share? Not a good way. That's why we use repositories. It's just like GitHub, just like Nexus, Docker Hub, Docker Hub. This is a public image library where you can upload your images and others can download it. For it, all you have to do is create an account and push your image. Just like GitHub, right? We create an account, we create a repo, we push our code. Similar here, we create an account, create a repo, push your code. Sorry, push your image, not code. Just a minute. Really sorry. If I remove both headset and sneeze, the recording is stopping. I tried that already, so that's fine. You have to bear with me. Sorry, yeah. Let's create a Docker Hub account. Username, password, sign up. Recommend signing with work mail address. Okay, let's try password. What? What the? Just I created. Just I, sorry. I missed. You should work now. Come on, load. Yeah, this is the Docker Hub. Just like GitHub, I mean, no change except here we push the images. There we just push the code in GitHub. That's it. So let me verify. I got a mail saying that verify. Let me verify in my mobile. Come on, verify. Yes, verified. Now ready for action. So create a repository, Docker Hub. We are going to Docker Hub. Earlier we used to go directly, but now these things came. That's okay. Repositories. Create a repository. We have two types, public and private. Public and private appear in Docker Hub search results. I told you, right? When you Docker search some image name, it will show you your image name also if you have the image pushed to Docker Hub public repositories. Others can download if they want. I mean, if they want, they can download. Private means only visible to you. But since it's a free account, so we can only use one private repository. Both are fine. I mean, there is no changes except it's visible to everyone, private not visible to anyone. That's it. So let's create a public. Both are same. So maybe my repo, my repo something. See, they gave some commands here. Pushing image. You can push a new image to this repository using CLI. These commands: docker tag, docker push it change. We'll be using the same commands. But yeah, let's create a repo first. Yeah, this is the repo. Currently nothing. If you go to tags, you'll see these are the images available, but nothing. Empty. Let's push our image to this repository. Yeah, Docker images, yes. So what is the first command? As you see in the Docker tag, we have to tag this image, tag this local image into a repo image. Tag this local image into a repo image. Why? Because first let's tag. Let's see. Docker tag. What what is the command? Is the Docker tag source and destination. It will be like source and destination. What is the source here? So our app, right? Nginx colon app. What is the destination? Destination is where we want to push. This is the my username. This is my repo name. This is the destination. Copy it. And what should be the tag after you push it? Colon. You have to give a tag. Engine. Maybe underscore v1 as an example. I tag my image. Let's see. We got new image now. But you observe ID is same because we just tagged the existing image and just gave a new image for us. Why I need to do tag? See, if you want to push a Docker image, you need to tag that image. Then tag that image as what? Tagging the image as the username to the repository of my Docker Hub account. This is what I use this username. And this is repository, my repo. That's what we created just now. Right? See, you have to use, we are just tagging the image of your existing image into Docker Hub username slash the repo name. Then only Docker Hub will identify that, okay, this is the image that I want to push. This is the image belongs to my account, my repo. Then it will push it. Otherwise, it won't. We can't simply Docker push Nginx app something like that. We can't do that. We have to tag mandatorily so that we are making sure Docker identifies the image before pushing. That's how we are using tag. Docker tag command, source and destination. Destination username slash repository. This is default. Username slash repository. Colon. What is the image name? What is the tag that you want to use? Something like it. Now you can push it. Docker push. Let's try. This is right. This you have to use because this is what you tagged, right? This is the tagged image. You have to push the tagged image now. Docker push this tagged image. Obviously, access denied. Why? Does the system have access to push to this repository? How it will know where to push? Even in GitHub, how it will know? Because we give access. How we give access? Either we log in, right? When we clone, it will ask for credentials or through SSH mechanism. Here also we have to log in. So we use Docker login for that. Username, press Agile, I think. Password, if I remember hopefully. See, login succeed. Now I logged into this account which I just created. Now when I push, Docker knows this username already, and the repo is existing within this account, so it'll work. See, even if you're pushing observe, it's pushing layer by layer. See, it's pushing layer by layer. Let's wait. Yeah, it's done. If you see this, it's done. Let's go. Let's go to tags. See our own. My image is there with this tag nginx v1, right? Now you can simply use it. See, use this command to Docker pull. You can download my image, which I just pulled. I'll keep in chat. You can download it. No need of account to download. To upload, you need an account. You can try this pull. It'll work because it's publicly available. If it is private, you can't pull it unless you have access. Unless I gave you access. That's it. That's how you push an image. You know how to pull an image, obviously. That's how we use Docker Hub. Let's create one more repo. Create one more repo. PVT repo. Private repo, obviously. Same thing. Nothing will change. Here, see, nothing. Same thing. Except you cannot pull it. Only whoever users I give access here, we can pull it. A collaborator is someone, just like Git collaborator, we add users. But I cannot add it, it seems, because I need to have some extra things. Because also designated in the commercial purpose that allowed for having administrators and deleting and mentioning the rest of it. Because I had to pay for this in order to add collaborators. So I don't want to pay. But remaining same. Let's push again maybe. So now Docker, I'll tag it. Docker tag nginx colon app. What is the tag I want to use? Press join username slash repo. What is the repo name? PVT repo colon nginx PVT. Something, some tag. Tag. Now Docker push to this. This is the tagged image. Paste enter. Is it pushing? It's already taking because see, it's the image is already there in my public repo within my account, right? Docker Hub account. So it's taking from there. Cache. Go to tags. See, it's there. You can pull it like this. If I add you as a collaborator for this repo, since it's private, I can't add you. I have to pay you. Sorry, I have to pay the Docker. How? I don't want to. So that's how you push your images. That's how you do it. Simple, right? That's it. Not just Docker Hub. You can use Nexus repository also to push Nexus, same commands. Docker tag, Docker push commands. Here, except Nexus username will come, Nexus repo will. That's it. Remaining same commands. Nexus, sorry, Nexus URL will come. My bad. Nexus repo URL will come. Colon the tag will come. Because Nexus provides not just for Java actually. Nexus provides uh, npm modules, Java as well as our Docker images also we can push. You remember Maven hosted repo is there, Maven proxy repo, all Maven in a group repo, all these kind of things. Similar way, Docker hosted repo will be there. Docker proxy repo will be there. So try that one. I don't have Nexus currently, but yeah, you try that one. You know what is Nexus, you know how to install it, how to use it. Try maybe by tomorrow's class, or by Monday's class. Try how to push your image to Nexus repository. Let me know. Got it? Any doubt in how to use this, how to push our Docker images to a repository? It can be any repository. The commands won't change, except the destination will change. That's it. I mean, where you're pushing it. That's it. Only that will change. Remaining all will be same. Any doubts so far in this tool? You can share it, but it's not allowing you share, and you have to be a pro account, I guess, in Docker Hub. If you bought a pro license, you can you can share it to others. I mean, you can add a user here. They have to have a GitHub account, sorry, Docker Hub account, and the username is there, right? Like this. You have to add the username here as in collaborators. But you cannot add C because mine is just free license, basic one account. If you want to add collaborators, you have to have pro license. You have to buy the Docker Hub. That's it. Change plan. Work with one collaborator per private repository by upgrading to pro. If I do pro, I have to pay. So if you take pro license, when pro plan, see pro is $5 per month. Why do I need $5? Just for testing. So if I pay the pro or team or a business like this, I can add the collaborators here. But if I can't pay, I'm bankrupt, so I cannot add collaborators. That's it. But generally you can do it. You have this. In offices, maybe let's say people are using Docker Hub, they'll have a business plans or team plans because multiple users will be there, right? Obviously, push pull, they'll have business plans. And some people don't use Docker Hub, they'll use Nexus or JFrog. Most commonly, they use JFrog or Nexus, not Docker Hub, because cost will be less as compared to because they're open source tools and private tools which we will set up by ourselves within our organization. Why would I pay for a public tool, right? Correct. So I mean that depends. Got it? Sorry. Any doubt? Any doubt so far? Cool. So apart from Docker Hub, we also have something called Registry, which is a private repository, just like Docker Hub, which is a private repository where we have to install that. We can use that to push our images. So just type Registry in Docker Hub, search for images. Yeah, this is the first one. This is similar to Docker Hub, but this is an image we have to run as a container within our machine wherever we use it, and we can use this uh, as a repository to store our images. But we have to run this as a container. We have to run this as a container. Where you run anywhere in our machine, not exactly in the same machine, wherever you feel comfortable. So what is the command? This we have to run as a container. The port is 5000, 5000. Name registry. What is the image? Registry. Oh, sorry. My bad. I'm forgetting the commands. It's pulling the image. Let's see. Yeah, this is a repository, a private repository where you can use this. Some organizations use this also. What they'll do is they have a separate machine for this, and they'll run the registry container. And what they do, they'll push the images to this registry. Everything will be stored in Docker container, and they'll pull it. Now imagine your Docker Hub is not maintained by you; it's maintained by some other guys, right? It's in cloud. So you push to that and you pull to that. But this registry, you maintain this registry. You install this, just like Nexus or JFrog. You have installed this registry in somewhere in your server, and you're using that. It's your private repository, just like Nexus and JFrog. It's a private repository where you can push your images and pull from there. How to push pull? Same thing. Same thing. How to push? Let's try. Sorry, Docker tag and Docker push commands. Now, how to tag? Earlier in Docker Hub, we used to tag with username slash repo and whatever the tag we want. Now, how to tag is the URL of this, URL and port number of this. Sorry, Docker tag. What is the name? Nginx colon app. Now, how to tag the URL, IP address, let's say. In our case, we are running registry in the same machine because we don't have, but generally it will be a different machine. You have to give the IP address of the image or host name of the image. Since it's in my local, I can use localhost colon 5000. This is the URL, right? Slash, what is the image name? Nginx underscore v2. I tagged it. Docker push. Simply copy this, paste. So it's pushing to this container because the container is acting as a repository now, as a registry to store the Docker image. That's why we're pushing. How to pull? Just Docker pull. That's it. Docker pull Nginx. It's pulling. That's it. That's all. The commands won't change except the endpoint. I mean, except the destination endpoint is changed. If it is Docker Hub, username slash repo slash the tag. Since this is a private repository which is maintained by ourselves, there won't be any username. There will be an endpoint, an URL. That user URL slash the tag. Similarly, imagine Nexus you install now. Nexus will be URL will be there at some IP address slash colon 8081 port number. You give in this place you give that 8081 slash the repository slash the tag like that. This is a private repository where you can set up this registry, which is a private repository in some machine, and use that to store your images. Some organizations use it because it's free, and there is no need to add collaborate or something. Within the organization, whoever have access, they can able to pull the images from here. No need to buy any license. So this is good, right? And that too, it is running as a container inside one of my mission. So within organization itself, it is secure. People think like that also. If they can't maintain, except that we have to maintain it. That's it. If the server is gone, there is no backup, gone. All of your image is gone. But in Docker Hub, it will be safe. That's it. That's the difference. Same thing with an XSR repository. You install it, you maintain within your organization securely, privately. If that is gone, that is also gone. But people still use it because they're open source. They're free to use. All you have to make sure the backups are there. That's it. Got it? This is about the private registry. Registry, repository, both same. The name is registry. That's it. The port number is 5000. That's it. You got it? Private registry and Docker Hub. Docker Hub is a public one, of course. The Docker Hub is public. We have private repository also, which we can able to use. Will be secure. And I don't want use this at all. I'll use Docker save and load commands. Fine. If you can do, if you can share your image to multiple hundreds of your people every half an hour, whenever there is a change, you can use that also, no problem. All good. Whichever is comfortable for you, you can use it. There are two options. But if you're single guy, you are the CTO, CEO, HR, everyone, everything, that will work. But if there's a team, there's a group of bunch of people who will be working on the same, you have to use a repository. Anything, Docker Hub, this private registry, Nginx, JFrog, anything you have to use. This it will make your life easier. That's it. So that's about the repositories in Docker. Any doubt so far? Anything? So there will be, I think, four topics remaining in Docker. Monday, Tuesday, Wednesday. I think we can cover all those things. 3 days we can cover those topics. Do practice, yeah. So no doubts, we can close the call. Okay. So of course tomorrow Sunday no class. We'll start Monday 7 a.m. onwards with no change because this week I had a couple of meetings, couple of shifts which I need to attend. But okay, but this time no, it's all done. Okay, 7 o'clock morning. It will be good for you, good for me, for everyone. Got it? All right. Yeah, happy weekend. Do practice. Do remember that. Do practice, please. Yeah. Bye. Yeah. Now, where is this? On top, let's go. Let's build it again. Y2. That's okay. Docker build iPhone 3 something. Nginx hyphen F engine. It will fail obviously, but yeah, that's okay. Don't worry. That's okay. That's okay. Let's cancel. Sorry, sorry. The legacy build duplicate will be removed visually is install build x2. What they're saying is we are using Docker build, right? That will be removed soon. So that's called legacy builder. Install the something called buildx component. It seems you have to use this command to build images. That's okay. You can go to this URL. The future is going. I mean, Docker build will won't work maybe in near future. So you have to use this buildx. Buildx is a CLI tool that used to run Docker builds. Docker build is a wrapper around buildx. When we invoke Docker build, buildx interrupts and build us and the buildx script. So what happens is Docker build will be there. The command will be there. But internally, there will be something called build kit, and the agent is buildx. So this will take the arguments when you type in Docker build, and it will build images for you. So far, Docker engine will be the right that will be taking care of it. So maybe in future, I don't know the date. Docker engine don't want to take care of it, it seems. So build kit is the one which will take care of building the images. See, build kit is a server you have to install. It will handle the build execution. I mean, when you type Docker build, that will take it and do the execution. Client buildx. This will talk to us when we execute Docker build command. That's okay. It will take too much time. Don't worry. Not recent. Not anytime soon. That's for sure. Got it? Yeah. All right. Let's meet on Monday 7 a.m. I'll post in group also. Yeah. Bye. Bye everyone.